timer starts in 3, 2, 1, let's go. Welcome to this Exam Strategy Explainer. I'm your host, your optimization specialist, and your coach, and today we are literally treating your Cambridge AS and A-Level Mathematics 9709 syllabus like a competitive esports speedrun. Our main objective, maximizing your marks against the clock, specifically for Probability and Statistics 1, and zeroing in on the representation of data. We are talking about optimizing your reading speeds, deploying rapid execution frameworks, and completely eliminating wasted actions to conquer those high-tariff questions before your exam limit hits 0. Now, to show you exactly how this works, we're going to be analyzing the gameplay of two hypothetical candidates today. On the left side of our split screen, we have player 1, Alex. Alex is a completionist, but constantly gets bogged down detailing secondary evidence points, which causes massive time loss. On the right, we have player 2, Sam. Sam is a fast rider zooming at incredibly high speed, but constantly triggers marking penalties by skipping over crucial command word parameters. We're going to use their runs to optimize yours.
Okay, let's establish the absolute stakes of this map. Look at that number, 15. Why are we focusing so much aggro right here? Because Probability and Statistics 1, data representation questions, your stem and leaf diagrams, your box and whisker plots, histograms, and cumulative frequency graphs, they account for approximately 15% of your total marks in paper 2. That is a massive, massive chunk of your overall score, just sitting there, waiting to be claimed. In the grading arena, 15% is literally the gap between a C and an A, or an A and an A star. If your approach here is clunky, or if you're stalling out on trying to remember which axis gets the frequency density, your mark velocity tracker is going to tank. You are going to bleed time. But if you optimize your approach like a frame-perfect run, you're going to breeze through this section and bank all that extra time for the brutal probability questions later in the paper.
All right, here's our tactical agenda for today's run. Number 1, the blueprint. Number 2, the optimal route. Number 3, evading traps. And number 4, securing method marks. Let's jump right in.
Section 1. The Blueprint.
Okay, we are in Phase 1, dissecting the route metrics. The Cambridge assessment framework doesn't just want to see if you can blindly draw a box and whisker plot. They prioritize analytical depth over superficial breadth. They're actively testing your logical, structured reasoning across 3 completely distinct cognitive domains: knowledge and understanding, application, and analysis. Let's look at the difference between a time sink and a time save here. Alex, or slow player, reads a prompt and starts writing out a massive paragraph explaining what a median actually is. Total time sink. 0 marks awarded for textbook definitions. The examiner knows what a median is. Sam, on the other hand, executes a massive time save. Sam recognizes the command word compare, immediately calculates the medians of the 2 datasets, and writes one punchy sentence stating which median is higher and what that means for the data skewness. Boom. Full application and analysis marks logged in seconds. That's the blueprint you have to follow.
So with the active run timer counting down in the exam hall, why do so many students find applying these concepts to unfamiliar contexts so incredibly hard? I've seen it a million times. Candidates leak massive amounts of time because they haven't practiced deploying these core principles outside of comfortable standard scenarios. Let's say you open the test paper and the map layout is a histogram, but instead of the typical heights of school children, it's mapping out the atmospheric density of newly discovered exoplanets. Players panic, they freeze, they stare at the page while the clock just ticks down. But the math doesn't change. The frequency density formula does not care if you're measuring apples or alien planets. The players who lose marks here lack a systematic detached processing framework to handle the unfamiliar context. You have to strip away the flavor text and isolate the raw data mechanics.
Section 2. The Optimal Route.
Welcome to Phase 2, the Co-op Challenge Arena. I'm watching Alex and Sam run a live multi-part statistics question right now, and they are aggressively debating the fastest structural path. Alex wants to slow down and literally outline basic textbook formulas first. Sam is pushing to just throw a high-velocity analytical thesis right onto the page and skip the setup. They're both going to crash. Here is the actual, optimized 5-step procedural route that gets you max marks without wasting a millisecond. Step 1. Identify the key elements, discrete or continuous data. Step 2. Apply the relevant principles. If it's continuous with unequal class widths, you instantly trigger the frequency density protocol. Step 3. Execute your analysis with crystal clear working. Don't just punch it into your calculator, write the class boundaries down. Step 4. Verify your results quickly. Does a cumulative frequency of 150 make sense if there are only 100 people in the survey? No. Catch the error now. And Step 5. Present it in the exact appropriate format the examiner demanded. This 5-step combo is how you clear the checkpoint.
All right, time split check. Hit the pause switch on the active run timer for a second.
Look, before we execute this final top-band paragraph and lock in an A-star grade velocity, you need to optimize your own setup. Subscribe to the channel right now, ace the exams, and turn on all notifications. Whether you are running IGCSE, O-levels, AS, or A-levels, this is your ultimate tracking center to outpace the clock and beat the examiners. Okay, timer back on. The crucial point here is that high mark velocity relies on your very first 60 seconds being pure unadulterated extraction. Deconstruct the prompt before you ever put your pen to the final answer sheet. Our player Sam just hit a structural roadblock. Sam tried to write an analysis, but the evidence dropped completely out of alignment, slowing down the mark tracking. To fix this, you deploy the peel structure as an optimization template. Point, evidence, evaluation, link. Make your point about the data, drop the raw statistical evidence you extracted, evaluate what that variance means, and link it back to the exoplanets or crop yields or whatever the question is about.
Section 3. Evading Traps. Welcome to Phase 4, the interactive viewer time trial. I'm handing the controls over to you. We are going to look at the top 3 mistakes pulled straight from the official principal examiner reports. These are the traps that instantly drain your mark tracking. Trap number 1, forgetting proper format. This means drawing a histogram with raw frequencies instead of frequency density. Total run killer. Trap number 2, failing to check your presentation. Did you forget your axes labels? Did you forget the key on your stem and leaf diagram? No key means no marks. And trap number 3, providing generic answers. If the data is about the lifespans of 2 different battery brands, you cannot just say Group A has a higher median than Group B. You must say brand A batteries have a longer median lifespan than brand B. You must use the context.
Okay, viewer challenge. I'm putting a flawed student paragraph on the screen right now. I want you to spot the performance leak. Where are the lost marks? 3, 2, 1, time's up. Did you catch it? Look at the flawed run on the left. The student identifies basic similarities between 2 box and whisker plots, but completely ignores the context and fails to compare the actual spread of the data. That's a massive pacing error that costs 4 critical marks. Now look at the optimized run on the right. This is a top band clear. The player identifies similarities and differences, and they do it using what we call comparative connectives. Words like whereas, conversely, in contrast. They say the median of Group A is 45, whereas Group B is 30, indicating a higher average. However, Group A has an interquartile range of 20 compared to Group B's 5, demonstrating far less consistency. That right there, that is a high DPS, high damage answer that forces the examiner to give you every single mark available.
Let's do another 60-second time trial challenge. When you are hit with a high-tariff analysis question, you need to systematically evaluate the evidence quality. You need to identify limitations, like is the sample size too small? You need to note assumptions made. Did the cumulative frequency curve assume the data was evenly distributed within the class boundaries? Because spoiler alert, it usually isn't. You need to find alternative interpretations and assess the effect on the final conclusions. If you try to do this without a structured framework, you'll wander around the paragraph wasting time. But if you mentally tick off these 4 boxes, you're basically using a wall hack to see exactly what the examiner's rubric is asking for.
Section 4. Securing method marks.
We are approaching the final phase of this run, and this is the most critical strategic safeguard in the entire Cambridge syllabus. Read this principal examiner alert carefully. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. This is your save state, this is your respawn point. Imagine you are executing a flawless calculation for the variance of a dataset, but in the last 3 seconds, your finger slips on the calculator and you write down 42 instead of 4.2. If you just wrote the final answer, you get a 0, run over. But if you dropped your clear, step-by-step working onto the page before that calculation, the examiner sees your formula, they see your substituted values, they give you the method marks. Your process is your ultimate safety net, accelerating your score even if your final execution breaks down.
Consistently showing your working isn't just a desperate grab for partial credit. It is about developing professional analytical skills. You want to prove to the examiner that you are in total control of the data physics engine. When you apply the correct formats, when you plot your cumulative frequency precisely on the upper class boundaries and not the midpoints, when you use appropriate, sharp terminology instead of vague descriptions, you are evaluating your own performance in real time. This is what we call the final 5-minute quality review pass. You don't just finish the test and put your head down. You use the last 5 minutes of your run to scan for missing units, missing labels, and missing context. As we watch our mark velocity tracker absolutely skyrocket to 100%, here is your mandatory post-game homework. If you want instant recall of these data representation formats under immense exam pressure, you need a memory hack.
Create a mnemonic right now using the first letters of the key terms. S for stem and leaf, B for box and whisker, H for histograms, and C for cumulative frequency. S, B, H, C. Superbrains hack Cambridge, speedrunners beat hard clocks. I don't care what it is, whatever works for your brain, lock that mnemonic into your pre-game lobby routine so you never blank on your formatting checks when the real exam timer starts.
All right, that is the victory screen. We just optimized your entire route through the 9709 data representation map. Let's distill this into our 3 universal optimization rules. Rule 1, the 60-second command word scan. Rule 2, the marks per minute budget allocation. And Rule 3, the final 5-minute quality review pass. To lock in this A-star grade velocity permanently, you need to subscribe to Ace the Exams right now. Click that notification bell so you don't miss our weekly speedrun tutorials where we break down every single module. And I want you to head down to the comments right now and tell me, which specific Cambridge unit framework do you find the hardest to clear under time pressure? Drop it in the comments, and we might just design our next speedrun route specifically for you. Keep practicing those past papers, keep optimizing your splits, and I'll see you in the next run. Timer stopped. GG.